Session 6, higher order functions. We've already been exposed to higher order functions using the built-in array methods. Yep, using the built-in array methods like for each, filter, reduce, if you've gotten to those. Those are higher order functions, but what is a higher order function? So higher order functions. Higher order functions are essentially just functions that operate on other functions. Now, what does that actually mean? It means they either take other functions in as their arguments or by returning them. So those are what higher order functions are. So functions, again, that take in functions as arguments or functions that return other functions. So for example, we have a function called add right here that just literally adds two numbers together and returns the answer. So like 1 plus 3, 1 plus 3 is the answer, return the answer, which would be 4. Likewise, we have a function over here called multiply, takes in two numbers and just multiplies them together and returns the answer. But now we have this, what is called a higher order function right here. It's called arithmetic. It takes in a number, or it takes in two numbers, num1, num2, as well as a third argument called calc. And calc is a function that we're going to pass into it. So right here, arithmetic takes in two numbers as well as a function as its argument, and then it calls that function that we pass in by passing in those two numbers, assigns it to that answer, and then returns that answer. So, for example, arithmetic, right down here, we're passing in the number 2, the number 3, as well as this entire function as its argument, or as an argument. So the function add is actually being passed in to the arithmetic function as an argument. And now when we're down here, we call the add function right there. This is essentially calling add num1 plus num2 right here. We're kind of reassigning it, call a calculation, because it could be an add, it can be multiply, it can be division, it could be a number of different calculations. What questions do you have about that type of higher order function?
When you're adding add as a function in arithmetic, how come you don't have to add the parentheses next to add?
So thank you so the parentheses, so if I were to say add with two parentheses invokes a function. What that means is it executes that function in place right there. So anytime you have a function followed by the parentheses, like right here, arithmetic, parentheses, it is going to run this function, arithmetic. Here we're just literally adding this entire thing into it as an argument. So now we have access to this entire function throughout the arithmetic function, in which we invoke it right here. This is where we're actually calling the add function. So that's what that looks like right here. That's it actually being invoked. We're assigning that whatever this value is, returns to this answer, and then we just return the answer again. Good question. What other questions do you have? All right. So why do even higher order functions exist? Well, we want to reduce the complexity of our code. We could have just done arithmetic that just says like, hey, instead of passing in a function, we could have just passed in like a string of add, multiply, subtract, etc. into here. And then within the arithmetic, we can have just done a bunch of if statement. If, calculation equals add, like a string add, or calculation equals a string multiply. But this allows us to reduce the complexity of each function, as well as we can use this specific function somewhere else and not just in arithmetic. All right, let's kind of jump into some examples. So higher order functions. So again, higher order functions are functions that operate on other functions either by taking them in as arguments or by returning them, are called higher order functions. Let's kind of do what we just did. We have an add function that takes in 2 parameters and returns the addition of them. Likewise with subtract, multiply, and divide. Divide, multiply, subtract.
Can you zoom in, please?
Oh, yep, thank you.
Thank you.
All right. So now what if we wanted to create a function that just adds 5 to the value of each and every one of these? So if we say like let add 5, just add 5 to answer, just for whatever reason, we can take in, a num1, num2, and then some calculation. And this calculation is going to be a higher, or this calculation is going to be another function that we're going to take in as an argument. So just like in the slides, and say let answer equals calculation num1, num2, and let's console log answer right here. What's going on? Why is this bugging out right now? So let's just try to see what this looks like. So we have, let's do multiply. So I'm going to add 5 to answer. I'm going to invoke this function by adding 2 and 10. And then also I'm going to pass in the multiply function right here. So I'm passing in the multiply function. Multiply is being passed into here. Multiply num1, num2, num1, num2 returns num1 times num2, which should be 20 is the answer. And I'm console logging that. So if I run that, I get 20. Does that make sense? What other? Likewise, if I do, now that afterwards, let's actually finish this out. Return answer plus 5, because we want to add 5 to the answer. So if I do that and run this, the answer initially is 20, and I'm adding 5 to it. I should see 25. I can likewise say, subtract 20, 45, 30, and I run that, I get 20. So 45 minus 30 is 15, and now I'm adding 5. I can also do, 10, 2, and do divide, passing in that function right here. So it's coming into here, divide 2 or 10 divided by 2, that's 10. I'm sorry, that's 5 plus 5 plus 5 should equal 10 right there. So that's one way of higher order functions. So functions essentially just act like variables. Like you can just pass functions around and do what you want with them. Just like you would like a string or a number or an object, you can pass functions around. They all kind of act the same way. So let's keep on going. So you can do the same thing with like sales tax. Like if you wanted a sales tax, if you wanted to do like let Illinois sales tax, you know, you bought something at Walgreens amount and you want to know the total with the sales tax of Illinois amount equals amount, or I would say total equals amount times the sales tax Illinois 0.08, then like return the total. And you can do that for pretty much every single state. So you can do it for, you know, California, Texas, Wyoming, Washington. So I've got California sales tax and Texas sales tax. So there's like a couple of ways you can do this. Typically, you could initially say like let bill amount equals, you know, the amount and the state. One way you can do this is say like if you're passing the state as like a string, like you do just like 50 if statements. Like if state equals Illinois, use this one. Else if the state equals Texas, use this one. And then let's just say there's else, the last one would be California. That's one way to do it. Like, so if I run bill amount, I pass in, you know, 15 and Illinois as a state, I get 16.32. Is that right? Or 36. Or if I pass Texas and run it, I get $16. So yeah, let's actually change this. Let's run that again. All right. Cool. What the hell? Oh. There we go. That's more like it. So with bill amount is a function, and we'd have to have like 50 different if statements for the bill. But we want to make things a little complex, or a little less complex. We can literally just return you know, the state. So now like state function or state sales tax, and that's a function. We can say state sales tax, pass in the amount right there. And now instead of passing in a string, we can actually pass in, you know, Texas sales tax and run that, and we still get the same. So it's about reducing the complexity of functions to like breaking them down to the single most little calculation or little amount of instructions possible. So we're abstracting a more complex function and breaking it down to smaller sets, smaller functions. That's why higher order functions kind of exist and why they're efficient. So we're passing in the state sales tax as a function, and then we're invoking it with the amount. All right. What questions do you have?
For the actual code platoon program, how familiar should we be with these? Or do you guys go over it, or should it just be expected that we should be fairly comfortable with these coming in?
We don't go into a whole lot of depth specifically. We don't cover like, hey, higher order functions, but you should be familiar with them because they are around everywhere. So you see them every day, not every day. If you're manipulating arrays or if you're using built-in array methods like for each, those are higher order functions. Those do take in functions as arguments. So just be aware that when you use built-in methods like for each or reduce or filter, those are higher order functions. And you'll see them a lot as you get more into software development and you're bringing in, external libraries, which are just a bunch of code that other people have written to make your life easier. And you'll be using these libraries. A lot of them utilize higher order functions. So, yeah. They're around a lot of places. Let's cover one more. This one might be this is where it could be a little confusing. So I'm going to create a function that returns a function. So I'm going to take a function called create power of, and it just takes in the power of something. So if I want to take the power of 2, power of 3, power of 4, etc. So I can say power of, and it returns a function, an anonymous function that takes in a number. So again, if I look up here, functions that operate on other functions, either by taking them in as arguments, which we have been doing, all down here, we've been taking them in as arguments, or by returning them. So we're going to have a function return another function. So function return the number times, or the power of whatever this number. So this create power of function takes in a number and returns this function right here with passing in the power of number right here. So let's actually go ahead. And as I said before, functions are kind of like data types, like strings, numbers. You can pass them around as variables and stuff. So if we can pass around functions as variables, let's create a variable from this function. So I'm going to let power of 2 equals create power of, and I'm going to pass in the number of 2, power, like 2. So what this does is assigning a variable power of 2 is equal to this function create power of, which I'm invoking right here on line 57. I'm executing this function, and I'm passing in 2 into here, and it returns a function with num times, or to the power of 2 right here. So this power of 2 is a function, is literally just this. So like if I console log power of 2, let's see what happens. It's a function. And what that function is this. It's literally just like saying power of 2, let power of 2 equals that, but instead of power of, it's the power of 2 because I passed in 2 as an argument in the create power of function. So this is literally the same thing as doing this. And what's nice is that I can create this, I can have this create power of is dynamic. So if I wanted to do like, so hold on, before I make it a little more dynamic. So now if power of 2 is a function, I can call this function power of 2. So if I take the to pass in 3, as I said, I'm going to move that down here. The power of 2 is literally just like saying this, doing the same thing. So if I'm passing in 3 in here, return 3 to the power of 2 should be 9. Right there. 2 to the power of 2, 4. 5, 25. And what's great about this, I'm gonna clear that, is that I can say let power of 3. And now that's and say create power of and pass in 3. Now I've got a power of 3. I can do the same thing with 4, 4, 5, 5. So I'm creating multiple functions now, just with a different power of. So this power of 3, power of 4 function, and power of 5 function. It's literally the power of 3 function is literally like saying, doing that, same thing. Wait. Likewise with power of 4. This is the same thing. Likewise with power of 4 and power of 5. Let power of 4 equals function number return num 4. That's literally what the same thing. And likewise with power of 5. So now if I wanted to actually execute the power of 4 or power of 3, so power of 3, because it's a function, 3 times the power of 3, is it 27? Yep. What questions do you have about higher order functions? This is can get a little confusing, but just know that doing power of 3, invoking create power of, and passing in the number 3 is literally just returning this function right here, which looks exactly like this. And now you can invoke the power of 3 function right there.